Gretel. Today we're going to walk through a pretty advanced example of how you can use Gretel's Tabular LLM model to create new high-quality training examples that you can use for LLM training, fine-tuning, or RAG. Let's go ahead and jump right in. I'll send a link to the blog here. Here we've got a kind of in-depth walkthrough of the approach, really building on some research that came out of papers, including the Textbooks Are All You Need paper that came out this year, as well as Tiny Stories and a few other pretty neat research papers that are using synthetic data to improve the quality of LLM models. Let's go and do a full end-to-end example of how you can create this type of high-quality synthetic data yourself. To get started and follow along, just go to docs.gretel.ai. From there, we'll go to Gretel Models, Tabular LLM, and you can grab the Colab notebook here from the example section. So I clicked on examples. We'll go ahead and load this up in Colab, and we'll walk through the code. It's using Gretel's new high-level API. So really, the only lines of synthetic data you need are like 3 or 4 lines of code. Really simplified that in the month or two since this blog originally came out. We're going to go ahead and run through, and I'll walk through what's happening behind the scenes here. So first, it's going to initialize the Colab environment, and it'll be connecting to the Gretel service. So you'll need your Gretel API key. It's installing a few packages here. We're using the Gretel client, which will interface with TabLM. We are also using Keybert, which we are using similar to the approach in the textbooks and the Tiny Stories papers, essentially extracting key phrases and then guiding the model to create more diverse responses. And we'll talk about how that works. You can kind of see a neat example of it going through here. So it is installing the datasets here. We'll import the key libraries that we need. So still pretty simple here. Next, we're going to instantiate the Gretel TabLM model. So here you can see we're firing up Gretel TabLM in inference mode. So we'll get really fast real-time responses coming back. Pretty cool stuff here. I'll ask for the API key in just a second. After the API key, we are going to load up a dataset. So the dataset we'll use here is the Databricks Dolly instruction tuning dataset. This is a dataset that was created by Databricks employees, and it's meant to be used for instruction tuning LLMs. Let me grab our API key. We'll let this run. So we'll be loading this directly from the Hugging Face datasets. We can see the Dolly 15K, so 15,000 instructions. We are going to narrow in on one category here. You can change this and use different categories. The closed QA was a good example of like relatively complicated instruction and responses that people have put together. For this demo, we wanted to run really fast, so we're only going to have it process 10 records. And for each record, it's going to create 3 synthetic examples. What we're looking for is diversity in the examples, so really kind of filling in gaps that might exist in the original knowledge set using knowledge from TabLM model. So here we see it going through. We've got our nice data set filtering code here, which is cleaning and filtering the data set to make it really easy for us to work with. You can see the results here. So here you have the original user-created instruction. Context, typically this is just cut and pasted from Wikipedia. And then the response, which is the response to the question that was generated by the Databricks user. Our task here is that we're going to create new synthetic instructions and responses for each set of context that we have to ideally give you better examples, fill in gaps, and describe things in a more kind of high quality textbook or teacher-student type of tone. To do this, one of the challenges any LLM has, if you prompted the same thing over and over, you're going to get the same type of response over and over again. So we have some simple code here that goes through and it uses a trained BERT model to extract keywords from the context. And we'll see some examples of what this looks like. So here we see that first record, it's been upsampled 3 times. It's extracted interesting keywords for each one, geology, evolutionary history for the first record here, different ones each time. And we're going to tell the model now when we ask it to create our synthetic examples, instead of just prompting it with the same context each time, we're telling it to have something around these select phrases. So create a new topic, new instruction response that's related to these phrases. And this gives us really nice diversity in the response and helps, essentially that leads to higher quality machine learning data sets. Here is where the meat of the logic is. So it's really in the prompt. Really following the methodology that was described in these research papers, we are asking it to create a high quality, step-by-step, teacher-student style instruction responses, things that require logical thinking, common sense reasoning, introduce the problem, and then frame your question around one of the phrases in the select phrases column. So this is one of the cool things about Tab LLM. It will take in tabular data, it will output tabular data. So now that we've got the prompt done, we're firing this up in edit mode. So we are submitting essentially this data frame that we've created, we just looked at a second ago, and we're telling it to create new synthetic instruction and response columns and add it to here. So here we can see the synthetic data. I ripped through that pretty fast. And let's go ahead and look at some of the examples here. So here, once again, we see the upsampled original questions. So we see this question being repeated 3 times. But now we see the guided synthetic instruction, synthetic responses. And what we're looking for is really high quality, diverse responses that will help the model that we're training on, like, learn this task. And we ask it to focus earlier. Let's go ahead and take a look again, just to refresh our memory. Geology, evolutionary history is the topic for this first synthetic example we're creating. So here you can see, here we're focusing on archaeology. So right on for what we're asking the model to do. And we see a nice response based on the context again around this synthetic instruction that we created. Next question anyone might have is, how do I assess the quality of the synthetic data, right? This isn't a traditional NLP evaluation task, like where you might use Rouge or Blue or one of the other evaluation metrics. So here, and this is really just an illustrative example, you'd want to run on more data to get a really high quality response, but we'll use Gretel's synthetic quality score. Essentially what it's doing is comparing the corpus of outputs versus the corpus of inputs and letting you see the score there. To get a high quality score, run on more examples, try running several hundred examples, but wanted this to run fast for the notebook. So here we can see a little bit of interesting information about the score. So the score is a composite score between text semantics, how similar is the text, versus the structure, keyword length, sentence length, things like that. We can see in the original data, average words per sentence was 14, synthetic data was 17. This makes sense. We asked the model to create high quality kind of textbook style responses. So it makes sense that the text structure here might be significantly different than it was in the original data. We get a nice overview of the types of data here. This is a great graph to use when you start generating data at scale, and you'll really see that if you generate a couple hundred examples and run it through. And then you get kind of a nice text structure distribution that you can look at just to really understand, how does the synthetic data quality fare against the original data that I trained it on? Is it meeting my expectations?